right, we are looking at target 5.6. Our mastery learning objective is I calculate the margin of error of a qualitative or quantitative data set. So we have qualitative versus quantitative. A qualitative data set is right, like a survey where you choose an option, right? So really that keyword is option here. All right, so for example, what is your favorite color, right? They might have like a red, a blue, a green, whatever. Where a quantitative data set is where like a survey or whatever, where you answer with a number. So these are kind of hard to define, but qualitative is really usually not numbers, right? I answered yes, I answered red, I'm looking for girls, whatever, right? Where quantitative is I have 3 siblings, I'm 72 inches tall, right? It more has numbers. So we have different formulas for both of these. The formula for a margin of error, and we'll say ME equals 1.96 times the square root of P, we say P hat, times 1 minus P hat, all over N. And I'll explain what these things mean. So P hat is your sample proportion. So the percentage of people that answered whatever one way you're looking for. Okay. And N is your sample size. Okay? So you have a sample proportion and a sample size. Our margin of error formula for a quantitative data set is the margin of error equals 1.96. And then it's times the square, that's not right, sorry. Erase that square root, times S over the square root of N. Square root goes on the bottom only for this one, so there are slight differences here. And S, in this case, where S is your sample standard deviation, and again, same thing, N is your sample size. So, kind of thinking back to probability, a lot of times we had to ask ourselves that question of like, which formula should I use? It's the same thing here. When you first look at your situation, you need to decide, is this a qualitative data set or is this a quantitative data set? Okay. So, example 1, out of a sample of 650, 38% answered yes to the survey. So what did they answer? They answered yes. This is qualitative, right? I'm just saying yes or no. Qualitative. Can't spell. I guess I answered that. I asked that question. So this is I cannot spell qualitative. Okay, qualitative. Okay, yes is not a number. So we're going to be using our qualitative margin of error formula. And we use the 1.96 because it represents what we're going to find a 95% margin of error. And this 1.96 represents something called a z-score for a 95%, blah, 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 blah. If you take statistics, this number could change. You can find different margins of error. We're not going to worry about that. Our number is always going to be 1.96. Square root of p hat times 1 minus p hat all over n. So I need to know what p hat is. Well, that's my proportion. This tells me it's 38% answered yes. So p hat is going to be 0.38. Make sure you put it into decimal. You cannot just leave it as 38%. Okay. And then n, again, n is our sample size. Well, there was a sample of 650 people. Which equals, well, p hat is 0.38. And then we have 1 minus our p hat. All over our n. Our n is 650. And then I'm just going to type that in my calculator. I'm just going to type this whole thing in. 1.96, control square root. I'm going to put, I think it's easier to hit control and the divide to get that fraction. So then I'm just typing in exactly what it is. And we get 0.037, right? Round to the nearest thousandth. 0.037. Which is actually 3.7%. So what this margin of error means, right, is in my specific sample, I got 38% said yes. But if I take other samples, I could be off by up to 3.7%. So if I take another sample, I could easily get 3% more, 41%, or 3% less, 35%. Okay, so I believe 38% is correct, but it could be about 3.7%. All right, let's look at our next set of data. The mean of a set of data is 53, the standard deviation is 13, and the sample size is 35. Well, as soon as we have like a mean being a number, right, a mean and a number immediately means it's quantitative. You can't have a mean of qualitative. So anytime you have a mean or a standard deviation, right, that's quantitative. So we're going to be using our quantitative margin of error formula. Six times s over square root of n. So let's figure out what our variables are. Our s is standard deviation. Oh, come on. And our n is sample size. So this equals 1.96 times, well, our standard deviation is 13, over the square root of our n, which is 35. And same thing, I'm going to type this in my calculator. So I have 1.96 times, again, since I have this fraction, I'm going to do control and then divide to get that fraction, and it's 13 over square root of 35. and we get 4.307. So same thing, I don't know what this data is, 53, a mean age of some doctor's office, I don't know, right? It is 453 when I took this random sample of 35 people. If I take another random sample of 35 people, I could easily get a mean of 57. Now, I would expect that, or 49, right? 4 above, 4 below, or anywhere in between. Okay, and we'll kind of talk more about that tomorrow as well. All right, let's look at our next example, example 3. In a simple random sample of 500 people, 342 reported using social networking sites on the internet. Is this qualitative or quantitative? Okay. 342 is a number, but that's not their answer. That's how many there are, right? So qualitative, if we're talking about how many people there are that are doing something, that's quantitative. Sorry, right? Again, their answer is not 342. Their answer is, I use social networking. That's a qualitative response. Okay. So I'm going to use my qualitative margin of error. P hat. Technically S hat, N hat too, but that's okay. So we need to figure out what our P hat is. Well, it's our proportion of people that answered the way we wanted them to. And in this case, 342 out of 500 answered the way we want them to. I can reduce my fraction, but I am going to keep it as a fraction to get the most exact answer possible. So this is, okay. So our P hat is 171 out of 250, and our N, well, there's 500 people. So our P hat is this whole fraction. Times 1 minus that whole fraction. All over, and our N is that 500. So again, I'm just going to type this whole thing in my calculator. So I have 1.96 times the square root of fraction. And then there's a second fraction, a fraction within a fraction. So much fun. So I have 171. Oop, sorry. This is being annoying. 171 over 250 times 1 minus another fraction, 171 over 250, all over 500. So I'm just typing the whole thing in at the time to have the most exact answer possible. We get 0.041. Which is 4.1%. Right? Not going to have you switch them to percents always, but sometimes we will. All right, let's look at our next example. You have just completed a study of TV viewing in your community. The mean viewing time for TV watched yesterday in the random sample was 164 minutes. The sample standard deviation was 85 minutes, and the sample size was 400. Is this qualitative or quantitative? So again, we have to ask, what did the people actually answer? Was their number qualitative or quantitative? Well, they answered, I watched 164 minutes of TV, right? So this 164 minutes is their actual what they're answering, which is a number, so it's quantitative. Okay. So our margin of error formula is 1.96 times s over square root of n. Our s was 85, and our n, the sample size was 400. So that equals 1.96 times, right? Well, s is 85. Didn't turn blue, that's okay. Over the square root of, and n is 400. There it is. So we have 1.96 times 85 over the square root of 400. And we get 8.33. So again, this sample had a mean of 164, but it easily could be anywhere between 8 below that and 8 above that if we take more other samples. All right, we're going to look at example 5 and example 6 in class tomorrow because I want to make sure we all are able to type things in our calculator correctly. So I will see you guys tomorrow. Have a great rest of your day.